All right, Wildcats, we are done with the units about Earth science, mountains, volcanoes, tectonic plates, and all of the Earth's core. And now we're moving on to physical science. And first, we're going to start out with heating the Earth in Chapter 5. Heat moves in a predictable flow from warmer objects to cooler objects until all objects are at the same temperature. Now you're thinking, wait a minute, some places like the desert are hot, and other places like the North Pole are cold. So how can they all end up at the same temperature? Well, something's changing. Weather, the sun, things are causing those temperature differences. But if you leave things alone, the warm energy will flow towards the cool energy, and eventually things will be all the same temperature. Many phenomena on Earth's surface are affected by the transfer of energy through radiation and convection currents. So radiation is like the sun makes you feel warm if you're outside, or those little satellite dish-looking heaters that if you stand in front of them, they make you feel warm. Convection currents are when matter is actually moving. So a good example would be like if you're super hot and you stand in front of a fan and the air is blowing across your skin, that will cool you down. Okay, page 178. Heating Earth is Chapter 5. Lesson 1. Earth is about 150 million kilometers away from the sun. How does solar energy reach Earth through space? So if we're so far away, how does the sun's energy get to us? Lesson 2. The North Pole is very cold, while places near the equator are very hot. Remember, the equator is the middle of the Earth? Why do different regions of Earth receive different amounts of solar energy? How can it be so cold at the North and South Pole, but it can be hot in places like Ecuador and Brazil? Lesson 3. Inside this balloon, hot air rises and cold air sinks. How do motions like this distribute thermal energy throughout Earth's atmosphere and oceans? Okay, so if hot air is trapped in a balloon and it rises, how do similar things happen with our atmosphere, our oceans? How does that affect our weather and our climate? Okay, page 180, a preview of all the vocabulary. Page 182 is just a quick little idea experiment that they can do. Page 184 is where we're going to begin taking notes. Okay, first thing is the same. You write your name. We're in AVID 6 for AVID 6th grade elective 1/11/2021. Okay, our topic or objective is Science FNT, Chapter 5, Lesson 1. Okay, and then for the main idea essential question, we put that slightly over here. The title of this lesson is Energy from the Sun. Energy from the Sun. Okay, let's go ahead and read the main idea from the book. Waves carry energy, but not matter, from one place to another. So, waves carry energy / not matter. Energy from the sun travels through space as electromagnetic waves. Go ahead and practice saying that. Electromagnetic waves. Sun's energy, arrow, space, as electromagnetic waves. So the sun's energy travels through space as electromagnetic waves. Same thing that was here. Okay, next up, vocabulary. Atmosphere is on page 187. Go to page 187 and find atmosphere. Most are blocked by Earth's atmosphere, the blanket of air that surrounds Earth. So atmosphere, air surrounding Earth. Okay, the next one. Electromagnetic radiation. Make sure you practice saying these with me. Electromagnetic radiation. Page 186. 186. Electromagnetic radiation is energy transferred by waves that can travel through empty space. Electromagnetic radiation, energy transferred, waves, arrow, empty space. It's energy transferred by waves, and it can travel through empty space. Excuse me. Electromagnetic spectrum. Practice. Electromagnetic spectrum. Also page 186. There it is, but we have to go back for the whole sentence. The sun emits waves across the entire electromagnetic spectrum, which is a continuous band that includes all types of electromagnetic radiation. Okay, so a visual of this continuous band is down here. It says the electromagnetic spectrum. So if the wavelength is long, it's things like radios, and as the wavelength gets shorter and shorter and shorter, it becomes other named types of the electromagnetic radiation. Microwaves, the energy in a toaster, visible light, X-rays, and there's even more off to the right or off to the left. And as you go to the left, it's lower energy. As you go to the right, it's higher energy. Okay, so electromagnetic spectrum, continuous band, all E/M types. So it's a continuous band of all the electromagnetic types. Just like they said here, a continuous band of all the electromagnetic types. Okay, let's go back to our vocabulary, and the last one is wave, right here on page 184. A wave is a disturbance that transfers energy from one location to another. Okay, disturbance, X-fers for transfers, energy. So a wave is a disturbance that transfers energy. Okay, remember, as we're going here, you can always pause the video to write notes. Notice that I'm not spelling things out anymore. Now I'm making it just a little bit harder. You have to read along with me, write things down, pause the video as you go, and you're going to have to look in the book to make sure that you're spelling things correctly. Okay, here's the first section, waves and energy. So in red, waves and energy. Red pen, red colored pencil, red crayon. Write over it twice with your pencil so it's nice and bold. Make sure it's on the left side because I have folded the paper in half. Have you ever watched ripples spread across a pond or watched crests of water roll across the surface of the ocean? If so, you have seen waves. A wave is a disturbance that transfers energy from one location to another. Okay, so ripples / waves in water. Energy is the ability to cause change or to do work. Waves carry energy but not matter. For example, when a wave travels through the ocean, the water molecules move briefly from their rest positions. The disturbance that caused the wave is passed from one molecule to the next. As a result, energy is transported through the water. The water itself is not transported across the ocean. Okay, so what they mean is if you see ripples in a pond, there's a whole little chain of molecules. For example, let's say that these pins are the little molecules of water. This one might move down, and this one will move down with it, and this one will move down with it. And eventually this one will go back up, and this will go back up with it, and that goes back up with it. So the energy is transferring with the wave, but this molecule of water stays in the same general area. It does not move with the energy. Okay? Energy equals cause change / do work. And I put parentheses around work because work is a special term in science. And it's going to mean more than just what you think of like going to a job. Work means making things hotter or colder, moving objects, that sort of thing. Okay? Waves equal energy, zoop, not matter. I underlined not because that's very important, that the waves are the movement of energy, but the matter or the mass is not moving. Sound waves form when objects vibrate. To observe this, place your hand against your neck and make a noise. Okay, go ahead and do that. Can you feel your vocal cords vibrating? Musical instruments, barking dogs, and alarm clocks all produce sound because they all vibrate. So sound equals vibration, waves, with little quotes. Because, again, things are moving in a wave. Your vocal cords are vibrating, or the air molecules are moving, causing that wave, just like I showed with the pencils for water. The same thing happens in air. The air molecules will vibrate, moving up and down or side to side, and they transfer their energy to their neighbor, and then to their neighbor, and the energy keeps moving. But the molecule stays in the same general area. Okay. Like sound, light also travels in waves. Yet light waves do not need a medium or substance to travel through. They can travel through a vacuum, which is empty space. Okay, light, arrow, vacuum, zoop, quote, empty, space. So light can travel through a vacuum, which is basically empty space. Okay. Have you ever watched and listened to a thunderstorm? A thunderstorm. They're pretty rare here, but sometimes we happen to have them. If so, you may have heard a clap of thunder several seconds after seeing the lightning flash. So usually you see the lightning flash, that bright light, and then a few seconds later, and the big rumble. Especially if the storm was far away. This happens because of the different speeds of sound, waves and light waves. The different speeds of sound waves and light waves. The speed of light through a vacuum is 300,000 kilometers per second, or 186,000 miles per second. That basically means several times around the Earth in just 1 second. That is super fast. This is the highest possible speed in the universe. Light travels almost as fast as in air. By contrast, the speed of sound in air is much slower, only about 340 meters per second, or 1,110 feet per second. Okay, 340 meters per second, that's probably like about 4 football fields long. So that's a lot shorter distance in 1 second than going around the Earth several times in 1 second. Okay. So underneath light, we're going to indent and we're going to say fastest wave. Light allows you to see, and plants use the energy of light to make food and to grow. As you know, Earth's source of light comes from far away. This source is the sun. Okay, so underneath light and indented, C, zoop, plant energy. Sun equals source, zoop, hot. The sun produces light because it is very hot. All hot objects give off light. You can see this every time you switch on a lamp. The light bulb glows because it is hot. Okay, now this book is old, so this is only true for incandescent light bulbs or halogen light bulbs. In other words, old light bulbs that have that little filament or little wire inside them that glows bright orange or bright white, or the lights that you see like in your garage where it's a tube of glass and inside it kind of flickers on and then it glows. If it's an LED type of light, this is not how the LEDs work. A hot stove glowing red is another example. Okay, so sun equals source, zoop hot, parentheses, non-LED, close parentheses, light bulb, and we drew an arrow. So when light bulbs get hot, they emit light, but that's only for the non-LED kind of ones. LED ones work differently. Also, a hot stove is an example. So when you see that the stove is bright red or orange, it's so hot that it is giving off light energy. While the sun is very interesting to study, you should never look at it directly. Staring directly at such bright light can damage your eyes. Okay, main idea for just these 2 pages. A sequence. Explain what happens when you toss a pebble into a quiet pond. So let's think about a sequence of events. When you toss a pebble into a pond. Okay, when you toss a pebble into a pond, it causes ripples or waves in the water. The molecules hit by the pebble begin to move or vibrate in a wave. and that causes their neighbor to move. So energy transfers from one molecule to the next. Let's go ahead and put that in here. Okay, so energy from one molecule, molecule, to neighbor, neighbor. Okay, so if these are my three molecules, if the pebble comes in, boom, and hits this one and moves it down, this one's going to move down, and that one's going to move down, and down, and down, and down, and down. But eventually, it will come back up and try to be where it was. And this will come back up and up and up and up. And so you'll get that wave forming. But, okay, let's say the part that's missing right here where it says the but. Okay? When you toss a pebble into a quiet pond, it causes ripples or waves in the water. Energy moves from one molecule to its neighbor. But the matter does not move. The molecules do not move with the energy. Okay, where did it say that? Remember it said it somewhere right here? As a result, energy is transported through water. The water itself is not transported across the ocean. The water itself is not transported across the pond. Okay, up here, the sun is Earth's ultimate source of energy. We have that. The sun is a source of energy. In blue for these pictures, wave energy. Water waves, sound waves, and light waves all carry energy. So we have water, we have sound, and we have light. Which waves do you think travel the fastest? Okay, well, remember they talked about the lightning storm and gave us an example of why light is traveling the fastest. You see the flash first, and then you hear the sound. So light is the fastest wave. Okay, that is it for these first two pages. Good job persevering, and roar Wildcats.